Now let's explore a new way of writing sets, the set builder form. Unlike roster form, where we list out every element one by one, set builder form uses a mathematical condition or rule to describe the set. This form is especially useful when a set has many elements or when a specific condition defines which elements belong to it. It's precise, compact, and powerful. Here's the general structure of set builder form. We write A equals the set of all x such that x satisfies a certain condition. This is written as A equals braces x such that x satisfies a condition. You can also use a vertical bar instead of the colon. Both are read as such that. For example, the set of all natural numbers less than 6 can be written as A equals brace x such that x belongs to natural numbers and x is less than 6. This describes the same set as braces 1, 2, 3, 4, 5, but through a rule instead of a list. Even though it looks mathematical, the set builder form reads like a sentence. Here's an example. An equal brace x colon x belongs to n and x is less than 6. This is read aloud as A is the set of all x such that x belongs to natural numbers and x is less than 6. Here, the letter N stands for natural numbers and the symbol that looks like a curved E is read as belongs to. This form helps us define large or even infinite sets clearly without listing every element. Let's go through a few more examples. Suppose we want to define a set of all odd natural numbers. We write B equals braces x such that x equals to n minus 1, where n belongs to natural numbers. This gives us the set 1, 3, 5, 7, and so on. Now, consider the set of perfect squares C equals braces x such that x equals n squared, where n belongs to natural numbers. This defines numbers like 1, 4, 9, 16, and 25, all square numbers. The rule tells you how the elements are formed. So, why do we use set builder form? Because it's extremely helpful when the set has infinitely many elements. There's a clear mathematical condition. We want to avoid listing a long set of elements. Set builder form gives us a compact, rule-based way to define sets. Instead of writing hundreds of terms, we use just one general formula that defines the full set. To summarize, set builder form lets us define a set using a logical condition instead of listing its elements. It uses symbols like colon or vertical bar for such that and the symbol for belongs to define membership. Now that you understand both roster and set builder forms, you can choose the one that works best depending on the situation. In the next section, we'll dive into different types of sets, starting with the empty set, finite sets, and infinite sets.